Hello guys, welcome to my channel. In this lesson, we are going to review algebraic proofs. And we are going to use algebraic proofs to complete what we're given right here. So we're given that 2 multiplied by 3x minus 4 divided by 3 minus x plus 6 equal 10. And we will prove that x is equal to 20 over 3, meaning that the solution to this equation on the left-hand side, we go ahead and just highlight that. This equation here, that if we solve it, x is going to get the value 20 over 3. So in order to get started with the proof, we will discuss the tools that we're going to use to complete the proof. We need to know all the properties of equality, such as addition, subtraction, division, and down to reflexive, symmetric, and transitive property. All these properties can be used to complete algebraic proofs, but sometimes we do not use all of them. We probably just use a few of them to complete this problem here. Reflexive property, symmetric property, and transitive property are properties that we have been using. But then, I need to draw your attention to that and let you know that they are not strange properties. They are properties that you have been using. I probably don't know you're using them. All right, let's go ahead and talk about the given equation and then see how we can organize our proof, to show that x is going to come to 20 divided by 3. All right, so to get started, I'm going to show to you one format that we can use to present our algebraic proof, and this is called a two-column proof. Two-column in the sense that you can see this is a table, right? It's where you have statements and reasons. All right, so we're given the statements and just given the statements, and then we're going to figure out the reasons behind all the statements. All right, so let's go ahead and get started with the proof. All right, so the step number one is exactly what we are given. We're given two parentheses open or bracket open, 3x minus 4 bracket close divided by 3 minus x plus 6 equal 10. And this is what we're given. All right, so and that's exactly what we find in step one. So here we're going to write given. Given. All right, and we're going to go to the second step. Step number two, we can see that looks like the original given equation has been simplified to an equivalent equation. Let's see what they did here. If you observe from step number one, we had a denominator here, 3, but looks like it disappeared here. We can no longer find it. Again, on the right-hand side, we had 10, but now 10 becomes 30. Again, we had 6 here, and 6 becomes 18, and negative x here becomes negative 3x. What I see that they have done here, they probably have used, not probably, I think they have used the multiplication property of equality. They multiplied step number 1 by 3, meaning that they multiply each term by 3. So, and cross the 3 out. And in that way, we get 10 times 3 is 30, 6 times 3 is 18, and negative x times 3 is negative 3x. So all of these numbers, or all of this, each term in the equation in step 1 is multiplied by 3. So we're going to call this multiplication property. So by multiplication property, the equation can become simpler. We can simplify the equation from step 1 to step 2. All right, moving forward to step number 3, we're going to see what is going on here. Step number 3 here, we had 2 parentheses 3x minus 4. But when we move to step number 3, we do not have parentheses anymore, meaning that they have used the distributive property. So that's 2 times 3x is 6x. You can see that. And 2 times negative 4 is negative 8. And they dropped negative 3x and they dropped 18 and kept everything as the same. So we can say that the property used here is the distributive property. And next, we're going to see how this equation reduces again. So here we can see that we had 6x here, and we had negative 3x here. All right, we had negative 8 here, and we had, let me use different colors. We had negative 8 here, and then we had positive 18 here. But 30 did not change. But we can see that we have 6x reducing to 3x. Probably there's a subtraction here, but the subtraction is not done on both sides of the equation. Again, we see that negative 8 is combined with positive 18, and that is given positive 10. So what we're doing here is a replacement, meaning that you're replacing 6x minus 3x by 3x. So this is not adding 3 to both sides or subtracting 3 from both sides. So this is not it. So you have negative 8 combined with 18 given what? 10. So we are not subtracting from both sides or adding to both sides. So what we're simply doing here is replacing. And replacing means substituting. Okay? All right, so that means step number 4 will be substitution property, or you can say combined like terms. But because we do not have a combining like terms as one of the properties, the suitable property here will be substitution property. So every time you combine like terms, you're using the substitution property in disguise. All right, let's go to step number 5. Step number 5, we see that the 10 is no longer there. And this 20 has reduced to, 30 here has reduced to 20. You can see that. And the 10 here is not there. So probably they have subtracted, or I think they have subtracted 10 from both sides. So that should go in for subtraction property. Subtraction property of equality. All right, so from this step here, we go to step number 6. And in step number 6, we look at here, dividing both sides by 3, we finally give us the final answer. So this is going to be division property. And if you look at how I am able to figure out the reasons behind how the equations are changing from one step to another, I am looking at the, the previous step and then coming back to the step that I'm on. So I will, look up and look down. So this is what I'm doing. I'm comparing step 5 to step number 6, because in order to know what's going on, I need to look at the previous step and connect the previous step to the step that we have right here. Oh, right. So that's why this is how I'm able to fill in the reasoning part. So you have the statements and the reasons. So, and completing algebraic proofs, this is the strategy. You have to be able to connect what is happening prior to what is happening now. All right, so I hope that I've been able to remind you of what you've learned in Algebra 1. In geometry, we are going to also learn geometric proofs where we would need all this information. But then before we conclude, I would like to give you some examples on the reflexive property, symmetric property, and transitive property. So let's go ahead and talk about a reflexive property. So the example of reflexive property is when you set a number equal to itself. For example, we know that 3 equals 3. So which is just like a reflection of itself. You see, like when you stand in the mirror, you see yourself directly, against the mirror. You see your reflection, right? So 3 equals 3. Or for example, when you say x equal to x in general. So a number is any number is equal to itself. If you use a fraction, 4/5 equals 4/5. This is what you call the reflexive property. Okay. For example, if it was geometry, if you are looking at line segment AB is congruent to line segment AB. This is what you call a reflexive property. Or sometimes, if you use a reflection, if you're using a reflection, uh, it could be BA. depending on how you are looking at how the shape is being transformed. So let's look at another property. So another property of equality that we have here is the symmetric property from the word symmetry. For example, if 2 plus 3 equals 5, then 5 will be equal to 2 plus 3. So this is what you call flipping. So in this case, like you're flipping from left to right and not changing anything. So if 2 plus 3 is 5, then it means that 5 will also be 2 plus 3. Okay, for example, when you say you solve an equation, for example, you get x equal 3. If x equal 3, what does that even mean? It means that 3 is also equal to what? X. This is what you call symmetric property of equality. So if one thing is equal to another, it means that that other thing is equal to whatever you said equal to it in the beginning. All right, so this is what we're looking at today. So we are going to talk about uh, the last property, which is the transitive property. So transitive, transfer, so changing. Okay, for example, you have a x equal y. Okay, here we compare three things. Okay, if x is equal y and y equal 10, what do you think x will be equal to? So x will be equal to 10. This is what you call transitive property. Okay, if x equal y and y equal 10, it therefore means that x must be equal to 10. So this is an example of a transitive property of equality. Let me show you another. Another one is the substitution property of equality. The substitution property of equality is different than the one that we've seen here in this problem here is, for example, if you have x equal 10, all right, and then you have y also equal 10. So what would be the relationship uh, between x and y? So x is 10 and y is 10. So that means x is equal to y. So this is one way you can see substitution. Another way that you can see substitution is when you have, for example, if x is equal to y, and then you add 7 to x, okay? So you have x is equal to y, and x plus 7 is 9, okay? So you add 7 to x, and it gives 9. What do you think you would get when you add 7 to y, okay? If you add 7 to y, what would you get? Would you get 10? Of course not. Think we have to correct this entry and say the result that we're going to get here will also be what? Will also be 9. This is a typo or a mistake. All right, so because we know that x equal to y, so it therefore means that if we add 7 to x and it gives 9, it also means that if we add 7 to y, we'll also get 9. So we can always substitute x and y in this situation. So this is the end of this lesson. I hope you have been reminded of your of the skills that you're bringing from Algebra 1. So make sure to subscribe to my channel, continue to watch videos, and I think you're getting ready for geometry. Thank you very much.